Hello everyone. In this video we're going to take a look at configuring Gre tunnels on the Cubro Packetmaster EX2, EX5-2, EX6, and EX12 devices. The configuration for Gre tunnels is slightly different on the G4 based Packetmasters, so there will be a separate video addressing those as well. Now, Gre, or Generic Route Encapsulation, is a Layer 3 tunneling protocol that lets us build overlay networks on top of an underlay network. And the generic part of its name refers to the fact that it can support any underlying or passenger protocol. Commonly, we'll see this being used with IPv4 and IPv6, but it's certainly not limited to that. And one common use case for a Gre tunnel is to extend an existing network like our local area network across multiple remote sites or geographic areas. So we can build a Gre tunnel between two sites or more sites. We can send traffic across that Gre tunnel to our remote site, thus crossing the public internet. But when it gets terminated at the other end, all of our layer 2 headers, such as VLAN IDs, as well as our private addressing scheme, will remain intact, effectively allowing us to extend our local area network across the public internet. In our example here, we're going to build a pretty basic Gre example. We're going to have an EX2 that is going to create a Gre tunnel and send traffic into it. And we're going to receive that Gre tunnel on another EX2 where that tunnel will be terminated, and then that traffic at that point can be filtered, forwarded, load balanced, whatever needs to happen to that traffic to get it to where it needs to go. There's a few criteria that we're going to need when we build our Gre tunnel, and that's going to be the tunnel IP address of each of our devices, the physical interface that we're going to bind our logical Gre interface to, and then the MAC address of those physical interfaces. This does require using the command line interface, but it's pretty straightforward. There's really only two steps. The first is we create our logical Gre interface, and then the second is we create whatever rules or flows that we need to either send traffic into that tunnel or receive traffic from that tunnel. So let's go ahead and do that now. Going into the CLI of our EX2, to create our logical Gre interface, we're just going to do a CV add port bridge 0 Gre1. And this is the name of the tunnel. This can be anything from Gre1 to Gre200. Then a -- set interface Gre1, type equals Gre. And then we're going to start filling in those options or those criteria that we saw on the example page. So the first of those is going to be the remote IP. This is going to be the IP address of the Gre tunnel that is receiving the traffic, the destination IP address. And this isn't the management address. This is an address which is defined by this command on the receiving tunnel. So in our example, this is 10.0.0.2. The next option is going to be the local IP. So this is the Gre tunnel endpoint address of the Packetmaster that's originating the tunnel, or the sending device. In our example, 10.0.0.1. Our next option is going to be to bind our physical port to this logical port. And in our example, we're binding port 4, so we're going to type in ETH-0-4. And then our final option is our next hop MAC. And this is the MAC address of the physical port that is bound to the Gre tunnel on the receiving device, so effectively the destination MAC address. And in our example, these are just some made-up MAC addresses to keep things simple. So we've created our logical Gre interface. There's a couple ways that we can check that. One of them is cc dump ports bridge 0. And when we execute that command, we'll see that we have this port 201 now. Port 201 is our logical Gre interface, and the naming convention goes that Gre1 becomes port 201, Gre2 becomes port 202, and so on and so forth. Another command that we can see our Gre interface with is ovs-ofctl show bridge 0, and we see our Gre interface right here. One final command that's really useful with setting these up is going into the config menu and doing a show interface tunnel brief. And this shows us our Gre tunnel with all the parameters that we entered during the command. So we have our local IP, our remote IP, our remote MAC, the port that it's bound to, as well as the logical port number and the name. Let's exit the config menu, and now we can start creating rules to send traffic into this tunnel. We can do a cc add flow, bridge 0, and our in port. Say we're going to take all the traffic from port 1 and send it through our GRE tunnel. So in port 1, actions equal output. And just like we would with a physical interface, we're going to enter our port number, but in this case it's port 201, our logical interface. When we do that, we've now created our flow. All traffic in port 1 is going out port 4, but it's going out port 4 in a GRE tunnel. And we can actually see that using Wireshark. So I'm going to start a capture, and I'm going to send some random traffic through our GRE tunnel, and we can take a look at that. That should be good. And when we grab one of these, we can see our GRE headers right here. It's also good to note that we can use all of the same filters that we would with setting up flows between physical ports when we use this to send traffic down our GRE tunnel. For example, we can filter on a protocol, we can filter by VLAN ID, we can filter by source and destination IP, MAC address, or port. So we can do something like a CC add flow, bridge 0, import equals 2. And let's take the IP protocol, and let's say we want to send all traffic that has a IP destination of 192.168.0.200, and we want to send that into the GRE tunnel. We can do that. And also note that when we go to the web GUI of the EX2, we will see these rules in our rule list. So we can see here our IP-specific rule as well as our generic one. Now, what if we need to delete this GRE interface? Again, that's pretty simple. We do a CV, delete port, bridge 0, and then the name of our GRE interface, which in this case is GRE1. That's going to delete our GRE port as well as any associated rules. When we do a CC dump ports, bridge 0, we'll see that we no longer have our port 201. Now, there's one additional step when we're setting up a GRE tunnel to receive traffic on an EX2 that we need to do for our receiving end. So let's go ahead and recreate our GRE tunnel. And let's change out the parameters here to reflect our receiving device. So our remote IP is now the .0.1, and our local IP is the .0.2. And we're going to have this bound to physical port 1. And the next top MAC would be the one ending in 11. Let's just check this real quick with another dump ports, bridge 0, and we can just grep that for a 201, and we'll see that we do have our port 201. Okay, the one additional step here is to do a CC add flow, bridge 0, import, and we're going to do an import of the physical port that our GRE tunnel is bound to. So in port 1, we're going to add the GRE protocol, and then we're going to do an actions equal GRE underscore decap, and then a dash capital O and open flow 13. This is a requirement for us to be able to receive the GRE traffic and terminate the tunnel before we make any rules. We're going to go ahead and put that in, and at this point we can create the rules as though we had been all along. So a CC add flow, bridge 0, and then an import for receiving traffic on our GRE tunnel. Our import is going to be our 201, and actions are going to be wherever we want to forward that traffic to. So we can say output port 2. And again, when we go to our interface, or web interface, we're going to see those same rules. So we have our GRE decap rule on physical port 1, and then all traffic coming in our logical GRE interface 201 is being output to port 2. So this is the process for creating GRE tunnels on the EX2, EX5-2, EX6, and EX12. Again, a separate video addresses the G4 devices as they're slightly different. But for now, thanks for watching, and take care, everyone.